Okay, so before we get started, you have to be able to define a couple of things, and you need to know what things are. So a tangent line. Tangent meaning it touches one time, and line means it extends in both directions infinitely. So it will be AX. You need an arrow on both sides of the line. I hope that you can see that. If not, there you go. Secant line. Secant meaning it cuts through the circle, it touches 2 times, and it is a line meaning it keeps going in both directions. That would be BX. Tangent segment. Segment meaning it has 2 endpoints, and tangent meaning it touches twice. So that would be AX. Okay. Secant segment. It touches twice. Okay. Secant usually means that it kind of extends past it, and it has 2 endpoints because it is a segment. So this will be BX. External secant segment. External meaning on the outside of the secant. Well, I know that it touches here, the secant segment, and then it goes here, and then it keeps going here. I'm looking at the external part of that, so that would be CX. And it's a segment, so it just keeps going. It's like that. And the chord would be BC. Take a second, pause it if you need, but make sure that you know all of these terms. If 2 segments are tangent to a line from the same external point. So I have my external point here, and you can't see that. Let's change the color. So I have an external point out here, and I have a tangent here, and a tangent here. And I'm going to estimate the center about right here. So when I do this, I know if this is the radius, right? I mean, if that's the center, I can do the radius here, the radius here, okay? And that says if 2 segments are tangent to a circle from the same external point, the segments are. So I'm trying to decide what's the relationship between this segment and this segment. Well, let's use our nifty proof knowledge, the things we already know. I'm going to create a segment right through here. Okay? And then I'm going to start doing things. I know that this is congruent to this because they're both radii. I know that these are 90 degrees because they are the tangent and the radius are always perpendicular to each other. As well as I know that this is congruent to itself because of the reflexive property. So when I look here, this triangle here is congruent to this triangle here. Therefore, I can use congruent parts of congruent triangles are congruent to say that this is congruent to this. So the 2 segments are congruent. Oh, wow. Let's see what this log is. Alright, so there's an example problem. Put it on pause and try to find AC. After you put it on pause, figure it out, push play, and the answer is 15. Alright.